Welcome to the Explainer. Today, we're diving into something that is fundamentally changing how we heal our planet. We are talking about soil remediation, that incredibly vital, heavy-lifting work of cleaning up contaminated earth after oil spills, industrial accidents, and decades of commercial use. For years, there's been this massive, invisible bottleneck in the industry that has frustrated environmental engineers and literally blown up project budgets. But today, we're going to explore how a fusion of new hardware and software has finally solved it. Okay, let's dive into this. I want you to imagine you're managing a multi-million-dollar excavation site. You've got heavy machinery rumbling, massive crews on the clock, and a strict ticking deadline to get hazardous chemicals out of the ground. Now imagine all of that grinding to an absolute halt. Why? Because you're waiting on a piece of paper. You are stuck waiting on off-site lab results just to tell you if the dirt your crew is currently standing on is clean or contaminated. Section 1. The soil cleanup bottleneck, the invisible nightmare holding back remediation. Because, as it turns out, cleaning up contaminated soil isn't just the physical challenge of digging and moving earth around. It is a massive administrative and logistical minefield. Traditionally, environmental teams have had to grab soil samples by hand, bag them up, carefully log them, ship them miles away to a distant laboratory, and then basically guess. They're left conducting what the industry calls blind excavation. They are literally digging up the earth while waiting for the data to catch up to the bulldozers. So the crucial point is right here, in what the industry is telling us about this outdated process. Laboratory costs are constantly rising, which stretches project budgets to the absolute limit. But the real project killer? That's time. Waiting weeks for off-site total petroleum hydrocarbons, or TPH, testing completely paralyzes decision-making in the field. Add to that the nightmare of critical data scattered across hundreds of spreadsheets, plus the growing pressure of strict compliance and auditing demands. It's just a perfect recipe for budget blowouts and delayed environmental recovery. Section 2. The lab in the field. Portable mid-infrared spectroscopy. Well, what if you didn't have to wait? What if instead of packing up the soil and sending it to a lab, you could bypass the traditional off-site laboratory entirely and bring the testing directly to the dirt? The old way meant waiting 2 to 3 agonizing weeks just to find out if your crew successfully hit their cleanup targets. The new way relies on a groundbreaking piece of technology called the RemScan MIR spectrometer. It's essentially an entire TPH laboratory, completely shrunk down into a portable device that you can carry right out into the field. 2 minutes. Just let that timeline sink in for a second. That is literally all it takes for this device to generate a highly accurate result right there on site. And it's not just for total petroleum hydrocarbons. You get soil organic carbon and even soil texture in that same window. You're going from a 3-week holding pattern to a 2-minute definitive answer. It completely flips the script on environmental pacing. Now, what's really interesting about this slide is seeing the actual hardware being used right down there in a dirt trench. The RemScan isn't some fragile piece of laboratory glass that needs a sterile, temperature-controlled room. It's a rugged, field-ready instrument built for harsh conditions. Crews are out there scanning the earth exactly where they dig in real time. And the analytical power under the hood is honestly incredible. Backed by machine learning and mid-infrared spectroscopy, this device has a massive detection range. It can accurately spot total petroleum hydrocarbons ranging all the way from 0 to 100,000 parts per million. Plus, because it's pulling texture, pH, and organic carbon data all simultaneously, you're getting a complete diagnostic profile of the soil right in the palm of your hand. Section 3. Mapping the contamination. GXLab, the central nervous system. Now, generating a high-quality data point every 2 minutes is awesome, but it quickly creates a totally new challenge. How do you organize and manage all of that rapid-fire information? To understand this, we have to zoom out from the physical hardware, the micro, to the digital software ecosystem, the macro. Think of the GXLab platform as the central nervous system that seamlessly integrates field collection, lab results, mapping, and compliance into one workflow. First, workers use an offline-capable app to navigate to precise jinking physical samples to digital barcodes. Third, the platform generates plume modeling to visualize the exact extent of the underground contamination. And finally, it spits out audit-ready reports with an unbroken digital chain of custody. And this brilliantly illustrates the two sides of that digital coin. On the left, you've got the mobile field app in action. It's built for folks operating offline in remote areas, featuring GPS tagging and direct navigation. On the right, you see how that field data instantly feeds into beautifully detailed desktop interpolation layers. It builds a heat map, a real-time plume model of the contamination right on your screen, completely replacing guesswork with precision mapping. Having this real-time data enables an incredibly powerful technique called soil grading. When you know exactly what the contamination levels are minute by minute, you can sort the excavated soil into specific concentration bands. For example, soil hitting 0 to 1,000 parts per million might only need cheaper bioremediation, while heavier concentrations get routed for stronger, more expensive treatments. It also enables excavation chasing, meaning you dynamically remove soil and redefine boundaries so you never overdig. You only treat the soil that actually needs it, which, as you can imagine, drastically cuts unnecessary costs.
Section 4. Global Real-World Impact. Scaling up the cleanup.
So we understand the micro-technology and the macro software, but let's pivot to the larger impact. Let's look at what happens when you deploy this combo to radically change massive remediation projects around the globe. Look at the sheer scale of the earthworks here. What we're talking about today isn't theoretical. It's not some pilot program in a small backyard. This technology is actively being deployed right now at some of the absolute largest and most complex cleanup sites on Earth. Let's move to and see how this builds across different environments by running through some impressive real-world case studies. In Kuwait, the Kuwait Oil Company selected this tech for a massive 114 square kilometer remediation program, replacing slow lab analysis with instant in-field screening. In Australia, it was used for a rapid spill response, allowing teams to make same-day diesel excavation decisions. And in Qatar, at the Al Corona Lagoon, they used real-time TPH delineation to keep a massive remediation project completely under time and under budget. 5 million plus. I absolutely love this number. This represents the millions of hectares of land globally that were managed using this environmental data platform in 2024 alone. It's just a stunning showcase of the massive scale of environmental restoration that becomes possible when you finally empower field crews with instant, actionable data. Summarizing this global footprint, it's pretty awe-inspiring how rapidly this lab-in-the-field approach has been adopted. With over 70 units deployed, operating in more than 20 countries, and successfully completing over 6,000 projects, this methodology is rapidly becoming the gold standard. When you see that it's trusted by world-leading entities like Chevron, Shell, and even the United Nations, it proves that solving the rapid remediation bottleneck is a top priority worldwide. And that brings us to our core takeaway, perfectly captured in this quote: streamlining tasks with real-time data to improve accuracy, efficiency, and the cost-effective restoration of environmental integrity. At the end of the day, why does any of this matter? What should you take away from all this? It matters because breaking administrative bottlenecks isn't just about saving companies money. It's ultimately about healing our environment faster, smarter, and with a level of precision that ensures the job is done right the first time. I want to conclude our explainer today with this final, provocative thought. If a simple 2-minute scan can completely revolutionize large-scale environmental cleanup, what other massive global bottlenecks could we solve by simply bypassing the wait and bringing the lab directly to the source? The future of field technology is incredibly bright. Thank you so much for watching. Keep questioning the status quo, and I'll see you in the next explainer.